Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
Good morning, Fred. This is Greg Hutchins.
Hey, Greg. You've talked a couple of times in the webinars, and I think you got one. It should come out, I think, right about the time this podcast comes out, about AI and things that are happening and stuff. And you've talked about regulations. You've talked about all the government activity and watchdogs and, bias and a whole bunch of other stuff in that. And I keep waiting for, what's going to be useful for me, dealing with a product design or setting up a factory and trying to get uptime working or maintenance or failure analysis. And I think I mentioned when we were chatting at the start, I brought this up with a couple other folks that were a little bit early for a webinar. And I usually open up the room a bit early and chat with folks and say, hey, what's on your mind, and ask them about any examples of good AI stuff for what we do. And other than a spell checker or maybe some coding, if you're trying to write some code to set up an experiment or look at something, there's no practical, useful application yet. And I see challenges of why that happens. And then you mentioned, well, that just means there's opportunities. So then I hit record.
Yeah. So as an early, my turn to talk, or?
Yeah, go for it. Yeah.
All righty. So as you know, Margot, my daughter, and I are doing products, AI products. And one of the questions that we have to deal with every day is what we call the POC, proof of concept. Mm-hmm. And part of that is, real fundamental questions. Who's the user? Are they willing to pay? Why are they willing to pay? How broad should this be? Should it be functional? Should it be broad? What's the look and feel, meaning the UI, UX? UI, user interface, UX, user experience. And we deal with that every day. So your basic question, AI, so what? Where's the value? That's sort of the downside phase of it. A lot of folks like me say, hey, this tool is going to change everything. So let me give you a hypothetical of what we're doing. We're basically developing a what is product around the pivot point of U.S. national standards. The pivot point for all U.S. standards and guidelines in AI is going to be something called the AI RMF, Risk Management Framework. The lens for all AI is risk globally, and we need standards. And the what is standards in the U.S. are the NIST, National Institute of Standards and Technology, Artificial Intelligence, Risk Management Framework. And oh, by the way, you can download it for free. So it's a great standard. Now for us, we know what we're going to do. So the next question is, what's the proof of concept? Meaning, will people pay? So part of the thing that we're adding to the app is what's called RAG. Now, can I go off on a little tangent on that for a second?
Yeah, I'm still waiting for it to come down from 50,000 feet. Come on.
Okay. So RAG basically is acronym for Retrieval Augmented Generation. And basically it's an app, decision-making, or, it's a decision-making agent that you can hook up to any product, any app, any phone call. And basically this is the bleeding edge right now of AI product development. So instead of taking information that's publicly available on, say, GPT-3.5 or whatever, you're basically designing your own Q&A system based on your internal data. That's the value set for reliability engineers. If you basically get data or use, publicly available data or LLM, you don't know how your data is going to be used, first of all, to train the model. And second, you might be revealing your data to somebody else's system.
Yeah. And that's one of the hurdles I see is that.
It's huge.
Well, no, I think from a very practical sense is that other than something that gets in the National Transportation Board, gets investigated, like the door hatch popping out on an aircraft recently, those things get reviewed and the results are made public. I think there's been, that happens all the time, but it's not very common compared to how many things we're learning from customer complaints and field returns and problems that don't jeopardize a plane full of people kind of thing. Car accidents do not get investigated and reported unless it's, like, what's the last one I remember that was a big investigation? And then it all got locked down by lawyers because they all sued each other and put everything under wraps, was the airbags going off all by themselves without provocation, basically. But the idea is that the industry of reliability engineering and to some extent quality engineering starts with this culture of, well, we don't talk about no failures. We don't have problems. We have products that work. We don't talk about failures. We don't go to conferences and do a case study about our recent issue that we had and how we solved it. We have to disguise that data. We have to transform it into some other data set and some other rhythm and beat to it. We have to, I know the military tried years and years ago, doing this big repository, collecting all this failure data and failure causes and all this other good stuff. And it was a tit for tat. If you wanted access to it, you had to contribute information. And it was, if I talked about all these capacitors we had failing and had decent data, then I could get access to more good data from other places. And it spiraled into oblivion because the vendors all sued them saying, you can't report our data. You signed an NDA with us. You can't talk about the failures. And our lawyers said, no, you're not going to contribute anything to that because somebody hooks that up that we said this vendor is bad. They're going to sue us for defamation. And so on and so on. So even internally then, that culture is, we have a horrible time remembering and learning from our own past failures because, one, we first deny that it's a failure or problem. Two is if we recognize it, we fix it quickly and forget it because we don't like talking about failures. And three, if we have some kind of record keeping on failure analysis and so on, it goes into that mythical warehouse of storage somewhere in the cloud that nobody knows where it is and how to find it. And by the way, at one point I was trying to find test data, not failure data, just test data that was being done every month on this one product at the factory. It took me 3 months to find a person that actually could send me the files. And I asked, why is this so hard to find? Because I don't know. I'm sitting right here. I'm not hiding anything. But you're the first person that's asked for this. Well, how long have you been maintaining this data? Oh, about 8 years. And so he was more than happy to work with me because nobody else ever pulled anything out of it. And the data was absolute crap. It was so poorly maintained and gathered and all that other stuff. It had so many artifacts in it that, yeah, maybe AI could help me filter that crap. But the idea is that we have this culture in the industry of reliability and to some extent product development and product services is that we don't talk about failures. And even on the maintenance side, I've worked with companies that there's 2 or 3 mechanics and technicians that are amazing, right? But they don't share what they know with anybody because then they're not amazing anymore. And on and on and on. So I see those as significant barriers to having a data set to train this stuff, internal or if we shared it externally.
Yeah. So you bring up a couple points. Let me bring up one quick story. So many years ago, I was basically building plants, energy plants like LNG and blah, blah, liquefied natural gas. And we started getting problems in the field and people got hurt. And immediately the feds were called in, to do their root cause and, see if there was somebody at fault. So I basically said, okay, these are our bad items. And legal came to me and said, no, 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 you can't use that term. And I said, well, what do you mean? We bought the stainless steel offshore and it said made in America, and the source was wrong, and this is, fraud and all types of stuff. No, 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 no. This is my first experience to legal and reliability, political correctness. They said, you really can't talk about defects or, attribute a flaw. We want to use words like nonconformities, nonconformance,
Yeah.
conformances.
Doesn't that mean that it's crap and it doesn't work?
It's for shit and it doesn't work.
Yeah.
Exactly. But legal got on my case, really hard. And I said, okay, great. Well, we'll do your correctness, reliability correctness talk. But back to your question, what's the value add to AI? This is what a lot of us are working on. We're taking our internal data that's proprietary and confidential, and we're putting all the legal stuff around it. Then we're building Q&A systems based on our proprietary data. Again, we'll have hookups, APIs to a ChatGPT or something, but the decision-making model that we build could be a decision model for root cause analysis, for FEMA, for almost anything in reliability, as long as you use your data.
Well, how much do you need though? How much do I? Because if I'm doing product development, and I was working in a like with inkjet printers, they had, I think, 3 good size product development teams. A handful of other projects doing this, that, and the other thing, but 3 teams were cranking out new printers regularly and updated at least annually and sometimes more often. And so that's, in a year, you might get 3 cycles by these 3 different teams. So product development, and they recorded a lot of data in the FRACA system, right?
Mm-hmm.
The failure reporting and corrective actions system.
Mm-hmm.
That might be a source of, now that I think of it, that might be a source of
field failure data.
Well, it's not. Well, the field failure data is too late. We're usually 2 generations away, and one of the pushbacks is, well, that was ancient history. We don't do that anymore. Although they did all the time. But the FRACA system is almost real time if it's being done well, and generally collects a lot of data. And one of the questions that I remember seeing a study on one time, and maybe AI could help in the prioritization of it, is going, just because you saw this one once and it wasn't worded exactly the same way as, this other case that we saw that exploded on us. Well, I shouldn't use that word, right? We're doing legal stuff.
Yep.
Rapidly disassembled. You might want to prioritize this one and learn some more about it. It could go through this. One of the hard parts about fracas is that the person writing it down may not be the expert in that field of where the issue is. And it may be just a symptom that could have multiple underlying pieces to it. And so the combination of the fracas system recording, observations and issues that were discovered, we also tend to write down, well, what was the corrective action? And in the better systems, when they're applied correctly, is we also write down, what we did, and then come back to it later and say, did that work? Did it get designed out? Did the problem ever reappear or whatever? It's really a mixed bag, whether you have a good set of records there. But when it's good, that might actually be a useful place for prioritization, for flagging things that should get another look, for looking for patterns in design practices, and that kind of stuff. So that might be a spot for it. But like field data, vast majority of the clients I've worked with in all kinds of different industries are selling all kinds of different products, and some medical devices, some consumer products, some commercial products doing, oil exploration, stuff like that. The amount of failure analysis done was appallingly small. It was very, very often, if there was failure analysis done, it was on a very small subset of the failures that were identified, and it's usually down to the replaceable unit. Oh, I replaced the hard drive and it works now, so it must have been the hard drive. Well, you and I in the audience all know that there's hundreds, if not thousands of ways that a hard drive fails. So which one caused the failure? And was it the hard drive's fault, or was it the power supply's fault, or did somebody drop it? So, but we replaced the hard drive and it works, so that must be the hard drive. Is such a common process in so many industries that the data set is just worthless.
But could you use the data to look for not the analysis, but look for patterns in the behavior or the types of failure?
I've tried doing that with companies. This one group had a habit of doing their field repair center. Their systems got shipped back to them for repair, and the repair center was driven by turnaround. Let's turn this device around real quick and get it back on the truck before it leaves the dock, kind of thing. And so what they did is they pulled out all the parts that they thought might have anything to do with what this failure description was, and stick it all, rebuild it. They basically gutted the internals to this device and then rebuilt it real quick on their bench. And they might have replaced 10 major subsystems in some cases, which is like 90% of the guts of this product. And now they have 9 modules that are perfectly fine if they didn't damage it on the repair process, and one that's bad. And they quickly figured out that it's not worth their time to figure out which one was bad because that's not their job to figure out what went wrong. And so looking at their data of what they replaced was, and we got a Pareto. They replace this one part more often than other ones. Well, let's get some samples of that and see if those things have any issues or not. And it turned out, not finding anything wrong with any of those units that we sampled, I went down to the line where they're doing the repairs. It was the one that was in the way of everything else. They always replace that piece because it was in the way of getting anything else out. It was, it was a victim of location. Not that it ever failed. Yet they were going to spin up a whole investigation and improvement project for that component because they'd had the highest replacement rate. Okay.
So let's get back to one of your products. We started the conversation by saying, what value does AI have for reliability and quality engineers? So, this is a big deal. So you and Carl, and I'll just make this a little bit personal for you and Carl. So you and Carl wrote a book, excellent book on reliability. And I went through it and I liked it. The thing that stood out was the fact that you and Carl focused on decision making.
Yep.
That was a big differentiator. And AI is very good at automating decision making. So could you take that book, for example, and come up with a series of questions for any reliability engineer to go through to understand what's the problem they're trying to solve, what's the root cause? 2, the input into your model would be your book and the thousands of podcasts and the thousands of articles you have. And essentially, you can come up with then questions that have focus, just think of it as a decision matrix. You could develop questions that would guide a rookie like me, for example, right, in terms of how to solve a reliability question, or how to make a decision regarding reliability, or how to report a reliability problem, or to do the 5 whys or a FEMA or a HALT. Every one of those follows a consistent pattern. So that's the decision making.
Yeah.
Those would be the queries. The data would be all this data, proprietary data you have in your books and articles and everything else. By the way, that's the essence of RAG, retrieval augmented generation.
Okay. And one of the hard parts and it was one of those things that Carl and I, in that process of writing, kind of said, well, how do we do that?
I remember. Yeah, I remember.
Yeah. And we're like, how did we, we look at a situation, we learn a bit about an organization, and we see where the barriers are, hurdles or gaps, I think is what we ended up calling it. And said, oh, you need to do this. And there might be 2-3 options available for that. In some cases, there's lots of options available. But it was a bit of understanding the organization and what they were capable of. Some of it is understanding what tools are available and what they're useful for. And we're documenting a bunch of that stuff. And a lot of our discussions on this show and others is about that kind of stuff. So I tried a question like that a couple months ago. I said, here's, I'm building this consumer product and, blah, blah, blah. And how do I estimate the life of this thing to meet our deadline? And I know a lot about accelerated testing, so it might not have been a fair question, but I try to give me a recommendation on a specific style because I kind of prompted it, the big constraint being time. So I had to do an accelerated test. I couldn't do real-time tests. So first thing it recommended was HALT, highly accelerated life testing, which is great by the name, but it doesn't give you an estimate of how long the thing will last. It just tells you what will not work. It shows you where the failures are, the weaknesses are. That was its first recommendation. The second one was do a demonstration test for the 2 years of the product's expected life. Well, it completely ignored the time constraint. And it's like, okay. And there's a lot of available data on the web in lots and lots of different venues, including Ascendo, that talks about like 6 different styles of accelerated testing and life testing and all of that stuff. And I like, yeah, we're not there yet. And that's with a very, very large data set. It might have been a bad question. I don't know. But I was like, I'm more worried about well, maybe you should create your first app around Ascendo, and I'll ask it some questions because I know where the answers are.
So basically what you're offering us is free with attribution, free use of your data set for Q&A, for reliability Q&A.
Yeah. No, and if it works, great. I'll host it and promote it, and you can sell your app. And if it doesn't, then it's like, so what? Never mind. I proved my point. There, I threw the gauntlet down I got to use old analogies here. Even when the gauntlet came out, that was new technology,
Yeah. I think with your data set, and by the way, you have multiple data sets. You have the articles, obviously, thousands of them. You have the podcast, which, you can do, you can generate, what do you want to call it? Words, right? You can generate.
Well, the transcripts, yeah.
Transcripts, exactly.
Up until recently, that's been expensive.
I've got a quick story just this week. So we know what KDP is, which is basically the publishing arm of Amazon.
Mm-hmm.
They forbade, whatever the word is, they didn't allow automated voiceover, for their books. They wanted a human to basically recite their books, right?
Mm-hmm.
As of this week, all those professional PowerPoint readers, they're gone. KDP, Amazon allows automated, well,
they've gotten pretty good.
They've gotten very good. So what I would do, just to start going back to your question, is take the data that you've got, retrieve it, put it into PDF files, upload it to a system, proprietary system. It would be closed, and then generate queries, decision-making queries for reliability quality engineers. And of course, the data would be chunked, just like, you've been developing an ontology for your website.
Mm-hmm.
The questions for your field, reliability, would have to be chunked. And then in terms of a decision tree, take rookies like myself, right, and actually sort of put them into a path for right decision making. There's no such thing as right decision making, but let's say highly reliable decision making.
Yeah.
That's the way I
defendable is the way I think of it.
Well, your word is defendable. In my world, it's reasonable.
Yeah.
You know, this same thing, same concept.
Yeah.
And by the way, this issue of gaps, it's a risk concept. You, Carl, and I discussed that when you were writing your book.
Yeah. Yeah.
So it's really risk-based thinking, essentially, or risk-based decision making.
Yeah. Well, it is, and we tried figuring out how to use that approach, and but we struggled with just how do we do it in a split second and get it, you know, and really help folks out, and then, but anyway, it's a challenge. It's a way to go. Now, if I'm going to wrap it up here, it's like because I think we've got a plan. You convinced me. There's a couple areas where it may actually be useful, and I'm willing to give it a try. There's no doubt about it.
Okay, we'll work on it.
Yeah. But if you're listening to this, and the same question to you is, what do you see as useful or not useful? I mean, we're seeing augmented reality things where you can see the internals to a pump, for example, or a device, and as you try to get it aligned or set up or troubleshooting things like that, and you can see checklists and all kinds of other things that are available to us to help us do our jobs. But where is AI? These large language-based models or similar type systems actually useful for you in what we do, whether it's running a control chart or interpreting field data, those kinds of things. Granted, I use Grammarly a lot, and it's kind of scary how much it helps my grammar, although not when I'm actually thinking and talking or typing. But the idea is what's working for you, and what do you see? Greg's looking at this as an opportunity to create something that's really useful for us, and other times I'm looking at it, well, how much data do you really need to make it useful? And so we'll give it a try. Let us know what you think. Is this something you'd like to experiment with and give it a shot, or you test it or evaluate it, or do you already have something like that and you're willing to talk about it and let us know about it? Let us know. Head over to ascendoreliability.com/go/SOR. There's a couple of ways to get in touch with us there. You can also find us at Greg and I and the other hosts of the show on LinkedIn or on our About pages. And not knowing exactly what date this is coming out in relation to where Greg's next webinar is, but I think it's really close. So on the random chance that this is before that, make sure you check out Greg's next webinar. I think it's on April 8th, if I remember right. And we'll be talking more about AI. Bring your questions to that. If we end up posting this after his thing, go check out the recording and let us know what you think. There we go. I knew I had both ends of that.
Yeah. Thanks for the plug. I appreciate it.
Right.
Yeah. I'm one of those people who sees AI as a real big money-making opportunity. So listen to my next talk in April, and we're going to be talking about AI regulations and product development. So anyway, look forward to catching up with you next month.
All right. Should be fun. Talk to you soon, Greg. Take care.
You bet. Thanks. Bye-bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.